Hello participants of the micro irrigation engineering subject. Now it is lecture 31. In lecture 31 we will deal with numerical problems related to micro irrigation system, mainly selection of the micro irrigation device, and some problems we will work out on the fertigation system. So, selection of emission devices, mainly drippers, how many number of dripper and what should be its capacity, and then what should be the capacity of the tank, or what should be the rate of fertilizer concentration it should be given. So, we will work out some problems. So, let us enter into the problem. So, the question 1 is on given here. A drip irrigation system is to be installed to irrigate 2 hectare area of a citrus crop to be operated for 6 hours, and we need to determine injection rate of liquid fertilizer when a ratio between fertilization time and irrigation time is 0.35, and the rate of fertilizing per irrigation cycle is 25 kg per hectare, means in each irrigation cycle 25 kg of fertilizer is to be given along with irrigation water, and concentration of nutrient in 1 liter is 0.2 kg per liter. So, this is the concentration of nutrient in the liquid. So, we are given area, that is a 2 hectare, we have been given the fertilization cycle, that is 25 kg per hectare, and then concentration of the liquid is 0.2 kg per liter. This is the ratio of fertilization time to the irrigation time, and then time of operation of the drip system is 6 hours. And we need to determine the injection rate of liquid fertilizer, that is QFI, and this is to be calculated by using the expression. This already we discussed in theory class. So, this QFI, that is the rate of injection of liquid fertilizer in liter per hour, can be given by rate of fertilizing, that is the quantity to be applied in per irrigation cycle. So, this is a FR to be multiplied with the area. So, this area is known to us, that is a 2 hectare, divided by the concentration C, that is 0.2 kg per liter, and then the multiplied by the ratio of fertilization time by by irrigation time. This is your ratio. This is also known to us. This is as given as a 0.35, and irrigation time is 6 hours. So, having given these values, one can calculate. So, just simply we are substituting these values, which is given as 25 multiplied by 2 divided by this concentration 0.2 multiplied by 0.35 into 6. So, this is a very simple thing, that we get QFI equal to 119.04 liter per hour is the rate of injection of liquid fertilizer into the drip irrigation system. Second question, it is to determine the total capacity of drip irrigation which is to be designed which is to be designed for banana crop of 2.5 hectare area. So, banana crop is grown in it is grown in 2.5 hectare area. So, area is given to us, and a dripper of 4 liter capacity is used for a crop which is having 2 meter by 2 meter spacing. So, each plant is having the area of 2 meter by 2 meter, and then there are total 6 number of operating stations in the field. So, this information is also available to us, that is N s equal to 6. We have been given area is 2.5 hectare, number of station 6, discharge capacity of a single dripper is 4 liter per hour, and then spacing means row to row spacing is 2 meter, and plant to plant spacing, that is SL, that is a lateral spacing, is 2 meter. The equation which is applicable in this case is QS equal to A by NS multiplied by QS divided by SR into SL. Now, K is unit constant, this is a unit constant. So, if we are using Q, means we want to get the discharge capacity in liter per second, area if we are using area in hectare, and the average discharge of the dripper QS in liter per hour, and then emitter spacing if I am putting it SR in meter, and then lateral spacing we are keeping in meter, then K is given by 2.778. So, having given these information, if I want to get discharge in liter per second, that is total system capacity liter per second, then these units are to be used in order to multiply with K as 2.778. So, these informations are very easily it is given, that is a 2.5 divide means area is given. So, area by number of station, that is 2.5 by 6, and then QS divided by 2 into 2. So, we get here 1.1575 liter per second. So, we can say that the system capacity is 1.16 liter per second is desired in this case. The question 3, it is we are required to determine the capacity of drip irrigation emission device, which is to be used to irrigate mango crop of 5 meter by 5 meter spacing, means each plant or each tree is having spacing of 5 meter by 5 meter, and then percent weighted area is 16%, means plant is at very early stage. Normally, for horticultural plantation like mango plantation, the weighting percentage is it varies from a very small value as it is given say from 16% to it goes up to 60%. So, it is in a very early stage, and we are not waiting for the entire area. So, only the part of area is to be weighted by drip irrigation system or dripper. The available operation time of means is 4 hours, means dripper or drip system is operated for 4 hours, and application efficiency of drip irrigation system is 90%. The depth of irrigation is 10 millimeter. So, depth of irrigation is known to us, application time is known to us, the the spacing of each plant is known to us. So, we will find out what should be the capacity of a drip emitter. So, this information is known to us as it is given 5 meter by 5 meter, wetting percentage is given as 16%, the depth of irrigation is 10 millimeter, time of operation is 4 hours, 90% is the efficiency. So, discharge of a single dripper can be given by area of one plant multiplied by the depth of irrigation divided by operating hours multiplied by this your application efficiency or system efficiency. Now, this area which is there, it is only the partial area to be weighted. So, this area is not 5 meter by 5 meter, which is for one particular plant, because plant is in early stage, it is not covering the whole area. So, at its early growth stage, it is only 16% of the area. So, this plant we will be, when we want to give irrigation with the dripper at early stage, this area is 4 square meter, and then depth is known to us, operating time is known to us. So, we can work out. So, depth is given as 10 millimeter, this is 4 square meter, and then the operation time is the it is 4 hours, and this is the application efficiency, that is your irrigation efficiency. So, this can be worked out as a 11.11 liter per hour. So, a dripper of one dripper of 12 liter capacity is sufficient. Of course, this is a higher size dripper, means we need to select a dripper which should not form runoff. So, if a single dripper is to be used, then it will be one dripper of 12 liter per hour, or we can have two drippers. We can have two drippers, which in that case our operation time has to be increased. So, means the selection of dripper will be made based on the particular type of the crop, how much is the weighted zone, and what is the type of soil. That selection is theoretical part as per the numerical values given in the question. So, one dripper of 12 liter per hour capacity is adequate to apply water. Question 4, here we are required to determine the number of emission devices needed for desired wetting pattern of 60% of banana crop. Okay, so, we need to find out how many number of drippers will be required. The spacing between the emission point and emission devices are 2 meter and 0.15 meter respectively. So, emission point 2 meter, emission device, that is 0.15 meter. The plant row spacing is 2.5 meter. This is another information. The maximum diameter of weighted circle found by single point source emission device for a given soil is 10 centimeter. So, 10 centimeter is the diameter of weighting made by a single dripper. So, we can say the soil is, when you see this particular value, one kind of interpretation one can make that it is a highly porous soil. So, weighting formed in the radial direction is lesser, maybe more depth of water going vertically downward. Now, in order to solve this particular question, these are the data which is given, means weight percentage, weighting area is 60%, L that is your 20 means the spacing between adjacent row is 2.5 meter, and then we are having the spacing between the emission point is 2 meter, and then spacing between the emission device is 0.15 meter, that is 15 centimeter, and diameter of weighting is 10 centimeter. So, when we are substituting these values in this question, we will we get the value that n equal to 100 multiplied by the weighting percentage, it is in fraction form, that is 0.6, S is given as 2 and L is given as 2.5, then dW is 10 centimeter, and the spacing between the emission device is this is 15 centimeter. So, keeping these values in centimeter, we will get number of emission device is 2. This is adequate to provide irrigation in the desired rate, and then so this way one can get the value. Now, we are I am talking about question 5. In question 5, we are given the values that we have we need to give water of 40 millimeter for a close growing crop, and we need to determine the concentration of nutrients in irrigation water when the ratio between fertilization time and irrigation time is 0.4, and the rate of fertilizing irrigation cycle is 50 kg per hectare. So, we need to determine the concentration of nutrient in irrigation water, and the data are given to us. Let us see detail that we are given depth of irrigation 40 millimeter, the fertilization ratio of the fertilization time to irrigation time is 0.4, and then the value of the we are given rate of fertilizing per irrigation cycle is in that is 50 kilogram per hectare. So, concentration of nutrients in irrigation water can be estimated by expression CF equal to 100 into FR divided by TR into ID. This is very straightforward. We need to substitute the value and one can get the concentration in ppm. So, FR is known to us. We will substitute 100 into 50 divided by 0.4 into 40. So, this will we will get the value of concentration of nutrient in irrigation water is 312.5 ppm will be the appropriate answer for this question. So, this is a straightforward question when this particular expression and their units are properly substituted. Question 6, we have been given the data that rate of fertilizer per irrigation cycle is 50 kilogram per hectare. The area of crop in which fertigation is to be given is 5 hectare. The concentration of nutrient in the liquid fertilizer is 1 kg per liter. This is high concentration, but we have been given this numerical problem. Let us work out what should be the capacity of fertilizer in the tank. So, these values are given. So, it is a very straightforward question, means the capacity of the tank, it is given by the CT equal to rate of fertilization per irrigation cycle, that is it is in expressed in kg per hectare, and then the area to be irrigated, this is given to us, that is a 5 hectare. We have been given the concentration of the nutrient in kg per liter. So, this is also known to us. So, we are just simply substituting 50 into 5 divided by 1 will give us the capacity. So, 50 into 5, that is 250 divided by 1. So, capacity of the tank is 250 liter. So, this is the answer straightforward. So, one can calculate. Now, these are the examples which I have given. Based on this, these means other problem, and then the designing the entire fertigation unit, these information and these expressions can be used to design the fertigation unit. So, you can refer for more examples by referring these books which are these textbook means textbooks for micro irrigation engineering subject. And so, in this particular tutorial problem, we discussed about the computation of the emitter capacity, how many number of emitters are required when irrigation is to be given, and we also worked out the problem which dealt with the how to find out the concentration of the nutrient, what should be the capacity of the tank, and we also worked out the given the data, how the capacity of the tank and other associated things it can be worked out. In the forthcoming lecture, we will discuss about the installation, operation and maintenance of drip irrigation system. So, thank you very much.